Hello and welcome to my channel. I hope we are all doing great. Today we are going to look at the concept of limits and calculus. With the concept of limits, we will be looking at the limits of functions. Under the limits of functions, we will look at the limits of functions to a point. We will also look at the limits of functions to infinity and the limits of simple trigonometry functions. Let us now look at the limits of functions to a point. When given a function f of x and a as a real number, then the limits of f of x as x approaches a will be equal to f of a. That is, we substitute the real number into the function. That is, we are going to put the value of a in place of x into the given function. In a case where we are to find the limits of a rational function, say limit of f of x over g of x as x approaches a, when we substitute the value of a and g of x is equal to 0, or both g of x and f of x are all zeros, then we have to first of all simplify the rational function before we substitute the value of a into the resulting function. Let's now look at examples involving limits of functions to a point. You can pause the video and try your hands on them so that we can compare answers. Let's look at the answers to the problems. With the first example, we have limits of 10x plus 2 as x approaches 4. So with this particular example, we just go straight to substitute 4 into the given function 10x plus 2. That is, in place of x, we'll put 4. So this gives us 10 multiplied by 4 plus 2. And 10 multiplied by 4 gives us 40 plus 2 gives us 42. That is, limit of 10x plus 2 as x approaches 4 will be equal to 42. I hope you had that. Now the second example, where we have limit of x squared plus x plus 2 as x approaches -2. This one too, we just substitute -2 in place of x. So this gives us -2 squared plus -2 plus +2. This will then be equal to 4 minus 2 plus 2. And this will be equal to 4. So, limit of x squared plus x plus 2 as x approaches -2 is equal to 4. Let's look at the solution for example 3, which is limit of 4x minus 3 all over x plus 2 as x approaches -1. With this, when we substitute x equal to -1 into the given function, we'll realize that the denominator will not be equal to 0. So with this one, we can substitute the value of x. It needs no simplification. So substituting x to be -1 by -1, we'll have 4 by -1 minus 3 all over -1 plus 2, which is equal to -4 minus 3 all over 1. And this will be equal to -7 over 1, which is the same as -7. Let's look at example 4. We have limit of x squared minus 4x plus 3 all over x minus 1 as x approaches +1. This, when we substitute x equal to +1 into the denominator here, we'll realize that into the denominator we'll have 1 minus 1, which will be equal to 0. Into the numerator too, you have 1 squared, which is the same as 1, minus 4 by 1, which is the same as 4. So we'll have -3 plus 3, which will also be 0. So the whole of this function will be 0 over 0. This tells us that we have to first of all simplify the rational function before we substitute the value of x to be 1. So simplifying, we are going to factorize this quadratic expression, and in factorizing that, we multiply the coefficient of x squared, which is 1, by the constant, which is 3. So when we do that, we'll get our coefficient or the value to be 3. So look for factors of 3 said that when we multiply them, we'll get +3. But when we subtract or add, we'll get back our -4. So we realize that the factors will be -1 and -3. So in place of -4x, we'll put -x, -3x. So simplifying this one, we'll have x squared minus x minus 3x plus 3 equal to x squared minus x. That is, we are factorizing them, minus 3 out x minus 1. So when we look at the first bracket, x is common. So this will now be x out, x minus 1, minus 3 out, x minus 2. The brackets are common. So let's pick one bracket and combine this term and that term. So that will give us x minus 3 in one bracket and x minus 1 in another bracket. So replacing that, we'll now have x minus 3 in bracket multiplied by x minus 1 in another bracket all over x minus 1 as x approaches 1. So this will here, x minus 1 will cancel x minus 1 here, leaving limit of x minus 3 as x approaches +1. We now substitute x into the expression x minus 3, and that will give us 1 minus 3, which is equal to negative 2. Let's look at the solution of example 5. For example 5, we have a limit of 2x squared minus 13x plus 15 all over x squared minus 25 as x approaches positive 5. This would then be equal to 2x squared minus 10x minus 3x plus 15 when we expand the middle term, that is the negative 13x. When we expand it, we have negative 10x minus 3x. So this one, simplifying, this would then be equal to 2x squared minus 10x minus 3x minus 15. That is when we factorize the top here. So, and the down one to 25 can also be written as 5 squared, which we can also factorize as x plus 5, x minus 5 from difference of 2 squares. So we'll now have limit of 2x out, x minus 5, minus 3 out, x minus 5. When we factorize 2x from the first bracket and factorize 3 from the second bracket. So when we do that, we'll now have limit of, we can see that the brackets here, the top, are the same. So we are just going to pick one to give us this. Then combine the 2x and negative 3 here to give us another term or another factor. So that gives us limit of 2x minus 3 by x minus 5 all over x plus 5, x minus 5 as x approaches positive 5. This would then be equal to, we see that x minus 5 is here, so this will cancel that, leaving 2x minus 3 all over x plus 5. And we can now substitute the value of x to be 5 here. So when we put x to be 5, we'll now have 2 multiplied by 5 minus 3 all over 5 plus 5, which will now be equal to 7 over 10. That is 2 by 5 gives us 10 minus 3 gives us 7. So limit of 2x squared minus 13x plus 15 all over x squared minus 25 as x approaches 5 will be equal to 7 over 10. Let's now look at example 6, which is limit of square root of x plus 7 minus 3 all over x minus 2 as x approaches positive 2. Because the numerator contains a surd, that is the square root sign there, we have to remove the square root. And removing the square root, we rationalize the numerator. In order to rationalize the numerator, we multiply the numerator by its conjugate and the denominator by the conjugate of the numerator. That is, we change the sign here to positive, and that gives us the conjugate of the numerator. So this would then be equal to limit of in bracket square root of x plus 7 minus 3. That is our numerator. Another bracket square root of x plus 7 plus 3. That is the conjugate of the numerator. Then over the denominator, x minus 2 multiplied by square root of x plus 7 plus 3 as x approaches positive 2. So this will now be equal to limit of square root of x plus 7 squared minus 3 squared. Since we have positive and negative between the terms here, they are alike, so we can apply difference of 2 squares. That gives us that. Then the down we expand. First of all, let's take x. X by root of x plus 7 gives us x root x plus 7. X by 3 gives us 3x. Negative 2 by root of x plus 7 gives us negative 2 root of x plus 7. Negative 2 by 3 gives us negative 6. This will now be equal to limit of x plus 7 minus 9. That is, square will cancel square root, leaving x plus 7 minus 3 squared is 9 over x minus 2. That is, when we combine this and that term, when we group them, have x minus 2 root of x plus 7 plus 3x plus minus 6. This will then be equal to x minus 2, 7 minus 9 gives us negative 2, all over x minus 2 root of x plus 7 plus x 3x minus 6. So this will now be, we have common terms on top and down here. So x minus 2 will cancel x minus 2, leaving 1 over root of x plus 7 plus 3x minus 6 as x approaches positive 2. Now, since we have simplified the rational function, we can now put in the value of x. So replacing x by 2, we now have 1 over square root of 2 plus 7 plus 3 by 2 minus 6. This will be equal to 1 over square root of 9 plus 6 minus 6. So the one will simplify. Square root of 9 gives us 3. 6 minus 6 gives us 0. So we'll now have 1 over 3. That is limit of square root of x plus 7 minus 3 all over x minus 2 as x approaches positive 2 will be equal to 1 over 3. Let's now look at the solution of example 7. We have limit of 3 minus x all over 1 minus square root of x minus 2 as x approaches positive 3 will be equal to limit of 3 minus x multiplied by 1 plus square root of x minus 2 all over 1 minus square root of x minus 2 multiplied by 1 plus square root of x minus 2 as x approaches positive 3. That is, we multiply both the numerator and the denominator by the conjugate of the denominator. So when we expand the denominator, we'll have limit of 3 minus x multiplied by 1 plus square root of x minus 2 all over 1 squared minus square root of x minus 2 squared, applying difference of 2 squares as x approaches positive 3. This will now be limit of 3 minus x multiplied by 1 plus root of x minus 2 all over 1 squared is 1 minus square here will cancel square root, leaving x minus 2 as x approaches 3. So when we expand the bracket, we now have 3 minus x multiplied by 1 plus root of x minus 2 all over negative 1 by x gives us negative x. Negative 1 by negative 2 gives us positive 2 as x approaches positive 3. When we combine group like terms, we'll have 1 plus 2. That gives us 3. Then we'll have minus x. You can see that this and that are common. So this will now be limit of 1 plus square root of x minus 2 as x approaches positive 3. Putting in the value of x, we'll have 1 plus square root of 3 minus 2. And 3 minus 2 is 1. Square root of 1 is 1. We'll have 1 plus 1, which will be equal to 2. Therefore, limit of 3 minus x all over 1 minus square root of x minus 2 as x approaches 3 will be equal to 2. Thank you very much for watching. Please subscribe to my channel, comment, and share for others to benefit. Bye for now.